Hi, welcome to another video in the Organic Chemistry Lab series. In this video, we will talk about the synthesis of dibenzalacetone. Dibenzalacetone is a compound that is used in the preparation of sunscreens. It has a conjugated structure, and this conjugated structure allows it to absorb sunlight and UV rays. So whenever I say conjugated, I'm talking about these alternating double and single bonds. As you can see, double, single, double, single, double, single, double, single. So throughout the whole structure, we have a lot of conjugated double bonds. This conjugated structure allows this compound to absorb UV radiation and makes it an essential component in sunscreens. So, dibenzalacetone has a yellowish structure. The molar mass is 234.29 grams per mole. Its melting point is between 110 and 111 degrees. It's insoluble in water, but it is soluble in acetone, and it's also soluble in chloroform. Dibenzalacetone was first prepared in 1881 by the two chemists. It's actually prepared by the condensation between acetone and two equivalents of benzaldehyde. So this is the equation of the reaction. Starting with acetone and two equivalents or 2 moles of benzaldehyde in the presence of NaOH as a base and ethanol as a solvent, dibenzalacetone can be prepared. This is an aldol condensation. This is an example of an aldol condensation reaction where 1 mole of acetone reacts with 2 moles of benzaldehyde to give the desired product. Now, why does this reaction occur in this way? Acetone and other aldehydes or ketones have this alpha carbon, which has an alpha hydrogen, which is highly acidic. So in the presence of a base, this hydrogen will be deprotonated, will be removed, and the corresponding alanine will lead to the formation of an enolate intermediate. So this hydrogen in the presence of a base will actually give us the conjugate base, which upon resonance gives us an enolate anion, which will react with the aldehydes to give the corresponding product, as we will see in the mechanism. Usually the collected product, which is the dibenzalacetone, can be recrystallized from ethanol. So let's take a look at the mechanism of this reaction. So again, starting with acetone, OH minus will abstract this hydrogen, and this will lead to the formation of the conjugate base. Now the conjugate base can of course resonate to give us the enolate anion. However, in order to make the mechanism simpler, we will just start the mechanism from this anion. This anion will react with benzaldehyde. I'm gonna write the structure of benzaldehyde like this. So the negative charge or the lone pair attacks here. This goes up, and this leads to the formation of this intermediate. So we have a phenyl. We have O minus here, a hydrogen, and a phenyl. Now this abstracts a hydrogen from water molecule, and this leads to the formation of this intermediate. Now this intermediate will undergo a dehydration reaction. So there is a hydrogen here again, which is an acidic hydrogen. Another OH minus will attack here. This will go here, and this will leave and this leads to the formation of the first intermediate, which is this one. Of course, we all know that OH is a very bad leaving group. So in this case, the dehydration reaction takes place because the obtained product is actually a conjugated product, and this is a highly stable product, and this is what makes the reaction possible. Now the same steps are repeated again. So again, starting from this compound by the action of base, so OH minus attacks here. This gives the anion. The anion attacks the benzaldehyde, another benzaldehyde molecule. This leads to the formation of this intermediate, which again gets protonated by water, and this will give us this, which again upon dehydration, so OH minus attacks here, this goes here, and this leaves, and this is how we get the final product, which is this one. So it's actually an aldol condensation reaction which is taking place twice. So this is the first aldol condensation which starts here and ends up here, and this is again the second aldol condensation which adds the second molecule of benzaldehyde to acetone, leading to the formation of the product. So this is actually the mechanism of the aldol condensation reaction, and this is going to be the end of this video.